In the heart of a forest of southwest China, a metal colossus hides. This gigantic structure is FAST, the most powerful and sensitive radio, designed and built by China. Mega structure seeks distant signs that can reveal the secrets of the cosmos. Secrets that will allow mailboxes and discover the force on which the expansion of the universe depends, and perhaps even capture signs of an extraterrestrial civilization. The first word that comes to mind is amazing. The figures are dizzying. The works lasted 10 years. They had thousands of workers. The working conditions were very hard. It is not easy to access the place. A steel structure of 5,600 tons, the equivalent of the weight of 40 blue whales. A reflector of 150,000 square meters, captures radio waves from the confines of the space. A receiver with 19 multi-frequency antennas that captures signals from the cosmos with a definition never before reached. It is the first time that one works on such a large scale, the first time in the world. We have followed the construction of this pharaonic project for 10 years. We are going to reveal the ins and outs in first. FAST, the ear of the universe. This is FAST, a gigantic radio. Its objective is to increase our knowledge of the universe. Belpo's radio waves from the confines of the cosmos. Wounds that optical telescopes cannot capture. It features 24 hours a day, 7 days a week. In FAST everything is huge. It is a metal monster of 10,000 tons. The reflective panel is composed of a huge mosaic formed by 4,450 panels. Numerous scientists have their expectations to make discoveries. The fabulous FAST adventure began in 1993. When astronomers around the world met in Kyoto, they observed a serious problem. In a few decades, scientists could not observe the sky from Earth. A nefarious balance whose responsible was none other than the man. The technological boom of the previous 30 years had caused terrible electromagnetic pollution imperceptible to the naked eye. Wounds that disturbed the effectiveness of radio telescopes. The future of radioscopes is not guaranteed. We will react before the man destroys our ability to capture radio waves. The root of the alarming observation, China suggested to build a radio telescope with a single reflector. It would be the largest in the world. A radio hell 100 meters in diameter that would allow listening to the universe waves with unprecedented precision and scope. The Chinese would give rapid access to scientists around the world. It was great. In the summer of 1994 the departure pistol was given. The first step was a difficult task. Engineers and scientists had to find the rare pearl, the ideal location to install the radio telescope. A challenge because the specifications was very demanding. To build such a large telescope you have to find a natural depression in a rock solid enough to support such a construction. Chinese engineers came out in search of a natural basin of at least 600 meters wide. They were equipped with a topographic measurement tool capable of detecting any minimum detail of the soil composition. They evaluated different places throughout China to find the perfect location. After more than 10 years of searching, sometimes comparable to that of the Holy Grail, they finally saw with a unique and exceptional place to southwest China. The first time I went, I found a magical place, a paradise. It was a wild place. First advantage, the natural basin of 800 meters in diameter was isolated. The nearest urban core is located at 70 kilometers. The distance met the first FAST requirement, to be protected from the radio waves produced by civilization. All radio interference had disappeared. You had the feeling of being completely alone, surrounded by hills. Second requirement, the soil should be able to withstand the considerable weight of FAST. The estimated weight of the megastructure was 10 tons, the weight of the Eiffel Tower. Another advantage, a very resistant cars, which fully met the requirements of the specifications. The rock is hard. Each square meter can support hundreds of tons. It met our resistance demands. Last, the basin had another advantage. The rainwater was perfectly drained. A flood would be a real disaster. There would be thousands of tons of metal, as well as very sensitive computer systems. The site met all geological criteria to house a giant radio. In May 2008, Chinese engineers and scientists decided to install FAST in that location. After 14 years of study, search and research, construction could finally begin. December 2008, a gigantic outdoor work was launched. Miles of workers who would stay in situ were hired to make a metal colossus. I tell you again, it is absolutely necessary to respect the safety standards. The place is dangerous and I do not want any accidents to occur. The teams of the work had to follow a multitude of steps to build the largest radio telescope. A considerable challenge that they had to overcome at all costs. At that time the depression was covered with trees and a leafy vegetation. I could not imagine to what extent the construction of FAST was difficult. The slopes were pronounced, restricted access and capricious climate. Electronic and Fast mechanics would not endure the lower flood. They dug a drain tunnel through the mountain. Fast had to remain stable, firmly anchored to the ground. The workers dug 200 wells more than 10 meters deep. They wanted to make sure the ground was resistant enough to install the radio telescope. They also built roads to guarantee the supply of raw materials. He worked incessantly. Employees, companies, nobody stopped. The work, which had a delivery date, was disturbed by the climate of the region, a mixture of acid rain and extreme humidity. If the workers wanted to comply with the provisions of the engineers, they would have to literally move mountains. Dynamite base, they created a kind of bed to install fast. March of 2013, the land was prepared, the construction could begin. The workers had to mount in the depression a steel ring of 1,570 meters in length to use it later as a frame of the telescope. First stage of the assembly. The soil fixation of 50 pillars that will serve as support for the steel ring. This ring weighs 1,600 tons. To mount it, the equipment assembled thousands of beams, welding them one by one. Each piece of the structure weighs several tons. D-Weight led engineers to completely rethink the scaffolding and elevation systems. We use a sliding support. This is the structure to which we later set the ring parts. We slowly slide the support to place it in the desired place. This ingenious system allowed to connect an average of a block per day. But a new problem arose, this time related to the laws of physics. Being steel, the ring was dilated according to temperature variations. The deformation was very significant between day and night, more than 30 centimeters. How could we control it? Engineers scheduled the works choosing the time of the day when the temperature deforms less metal. The best time was 3:30 in the morning. And after 6 months of efforts, Fast structural ring was going to be connected. The night of December 31, 2013, the last metal block approached its final position. The operation was very complex because the margin of error was less than 1 centimeter. At 11:30 p.m., the block fit into its place perfectly. The deviation that engineers had so much was less than 9 millimeters over 1,570 meters. That is, the precision was almost 100%. In January 2014, Fast had its skeleton. To capture signals from far away, I needed the largest reflective surface ever built for a telescope. A wave reflector meters in diameter. They installed it on a metal network that the workers had mounted with harnesses to more than 50 meters from the ground. To avoid the setbacks derived from the transport of the panels, the workers assembled them on the site. In this outdoor manufacturing plant, the giant network rests on hydraulic cats. That they will accurately guide the reflection surface towards the confines of the universe. In total, 2,000 cats were necessary. These pieces were also assembled in situ within this huge factory. Cats will have to support several tons of pressure for decades. To guarantee perfect quality and reliability, each piece was manufactured entirely by hand. Once the network was installed, they set the metallic mosaic formed by alveolar aluminum plates panels. We are talking about an 11 meters panel. 100 triangles were assembled. With this design, a stronger structure was achieved. A more solid structure, consolidated by some panels whose installation was the most dangerous stage of the FASTA project. Each of the thousands of pieces of this giant puzzle almost half a ton. In addition, each piece had to fit almost at the centimeter. The slightest deviation in the positioning could affect the entire reflective surface. Due to the gigantic size of the surface that had to be installed, we were undergoing a great pressure all the time that the works lasted. Despite this, the last panel of the Fast reflector was installed after a year of hard work. To celebrate the end of the first phase of the project, a balloon release was organized. It symbolized China's look directed towards the sky. The operations of the next phase were more technical, but equally risky. Fast needs an ultra-sensitive receiver to capture radio waves from the depths of the universe. The teams had to build 6 towers to hold it, each one 170 meters high. In the upper part of the towers there is a gigantic pulley that supports a 46 mm steel cable in diameter. At the end of the cables, engineers suspended the Fast centerpiece. The receiver, 30 tons and 13 meters wide. In the center, it keeps a treasure of technology. It is equipped with 19 antennas that capture radio waves. Antennae each can be configured to detect different frequency bands. Thanks to this possibility, they can capture frequencies that range from a milliprison to 7 GHz. With the data of the observations of each antenna, scientists will be able to observe immense and distant areas in space with a definition never before reached. All flight simulators use it. This mechanism allows you to point accurately to objectives located at millions or even billions of light years away. Many elements were very complicated to make. So, it was a challenge. It was that supplying electricity to the cabin, protecting it from the rays, allowing you to transfer your data and, of course, to be able to position it precisely. In November 2015, a prototype of the cabin was ready. The first elevation test could be scheduled. The cabin began to move. Nobody let go of the walkie-talkie. We were all attacked. At the end of a few seconds, the cabin was in the air. It had to reach a height of 140 meters above the vacuum. But there was still a great challenge to overcome. Fast engineers had to design and manufacture an exceptional cable. To fix it to the steel cable that supports the receiver. A cable that supplied electricity to the cabin. And above all, that guaranteed the transmission of countless data collected. It is a key technology and we had not yet discovered it. Without this cable we were stuck. The cabin produces a very high number of data. Every minute you need 22 gigabytes to store your observations. The equivalent of the storage capacity of a Blu-ray disc. To send these astronomical amounts of data, fiber optic cables are needed. But they ran into a problem. Conventional fiber optic cables can produce impressive transmission speeds but are extremely fragile. The engineers spent 4 years thinking about this puzzle. At the end they were resolved by creating the world's first flexible optical cable. The new cable is called curtain cable because it can be folded 100,000 times as an accordion. Es extremely flexible while ultra-resistant. The speed is exceptional. This cable allows you to transmit the data collected to the storage servers. To avoid any signal loss caused by distance, the servers have settled less than 500 meters from the radio. September 2016, the big day. The fast radio settings was going to be officially inaugurated in the presence of the Vice Prime Minister of China. In the equipment the tension was increasing. 10 minutes of the launch, a technical problem threatened to leave the cabin of reception in the soil. A problem with the laser beam could prevent the inauguration. Tell the person in charge that the problem must be solved as soon as possible. I notice it immediately. If the parameters are not precise, it is very dangerous. In the receiver's cabin, engineers had only a few minutes to solve the problem. You have to start the update immediately. Okay, the seconds passed slowly, but in the end, all good, the update has been completed. They can start. They were 15.30 local time. The problem was solved. The cabin could rise. After years of intense efforts, the construction of FAST came to an end. The most powerful radio telescope would allow a gigantic step to be taken in our knowledge of the universe. Out of 2016, this years of hard work, the giant of star observation was ready to explore the universe. It was launched in search of distant signals. In space, stars, planets and even stars' dust emit electromagnetic waves. They can be seen in different ways. There are many parasites, such as galactic atmosphere and dust. We cannot see them with the naked eye. But they exist. How can we observe them with our telescope? The best known tool to observe electromagnetic waves is the optical telescope, a telescope that captures the light waves. Like the VLT in Chile, the Hubble Space Telescope or the SALT in South Africa, all allow to make very precise observations. But they have a limit. The temperature variations of the atmosphere, the pollution or the solar winds divert the light waves that they want to observe. It is as when you want to make a medical diagnosis. Several filters are needed. We use X-rays, ultrasound and a visual exam. In astronomy is the same principle. To observe what is not visible, FAST focuses on radio waves. Waves that are detectable by optical telescopes. FAST is built and programmed to detect radio waves. These waves are the resonance of distant cosmic elements. When they find the huge radio telescope reflector, they bounce towards the receiver located 140 meters high. Thanks to the entire computer device that it has, the receiver converts the signals into digital data. They have developed a cosmic technology to be able to perceive the invisible. The mosaic that forms the fast reflector is subject to a metal network. A light, flexible and therefore orientable network, which allows the reflective surface to be deformable. The guidance of its thousands of panels can be adjusted with extreme precision. Mobility is secured by 2,225 cats. Each cat can be activated separately. It is a very sophisticated system, computer-controlled. It is impressive. With a simple command, cats move the reflector panels. The waves from space are oriented to be sent to the receiver. With this orientation precision, FAST can continually track the same light blue body. That changes things. The Chinese have put the bar very high. It is a great telescope to explore the cosmos. This unique technique of deformation of reflective surfaces is revolutionary. But it is not the only innovation of FAST engineers. To observe the unknown, they have had to go further. They have developed an automatic system that allows the receptor to orient themselves. For us, it was a challenge without preferential. With a 13 meters wide and 30 tons, the engineers had to think of solidity and durability. It all starts in the 6 towers. In the base, some superpotent engines pull the steel cable to which the receiver is connected. These cables will have to withstand the cabin for decades. If one of the clamping cables broke, for the telescope it would be like receiving a whippo with a whip of 70 tons. The impact would be brutal. And the risk is very real. Telling this is what happened in 2020. The Arecibo radio telescope was destroyed after the rupture of a clamping cable of one of its platforms. To avoid this type of catastrophes, FAST engineers decided on a braided steel cable of 46 millimeters, which in theory is unbreakable. And with caution, engineers adjust the length of the cables using traction engines. It allows them to place the cabin where they want, with optimal precision. The margin of error is less than half a centimeter for more than a kilometer of cables undergoing a 13th cabin and the entire suspended assembly at 140 meters high. To perfectly guide the cabin and thus be able to accurately capture the waves from the universe, FAST structure is mobile and deformable. But these were not the only capabilities developed by engineers. We have to slide inside the receiver to discover the fruit of their work. The reception tools are installed on a robotic platform. It is called Steward Platform, the name of the English that invented it. It is a very intelligent tool that allows the sensors to be moved on 6 axes with a millimeter accuracy. Resuming, FAST can deform its reflector. You can guide your receiver perfectly. Finally, you can adjust your antennas with millimetric precision. The triple adjustment system allows FAST to be the most accurate radio telescope in the world today. Although FAST's innovations were extraordinary, I still had to overcome the last challenge. FAST wanted to be operational all the time. The engineers had to be able to compensate for the rotation of the Earth. When turning on itself, our planet raises a real problem for any telescope set to the ground. Because its goal is not fixed. The most concrete example to understand it is to try to observe the moon for a whole night. It is not easy with a star that seems to move. FAST is also subject to these inconveniences. The teams then created an automated system capable of covering every square centimeter of the radio telescope. Create smart software to control this system, and the cabin is a real innovation. These applications allow engineers to modify the structure continuously. In this way, FAST can compensate for star movements and track objectives for hours and hours. March 2017, here began a counter-alloy race. All FAST elements were in place. Now they had to put them into operation. The future of the radio telescope was going to be decided in the adjustment phase, called purification phase. There are many difficulties when making large and very heavy machines. Precision demands increase considerably. Indeed, to deform a reflector that weighs several thousand tons and move a cabin 140 meters from the ground to observe areas located billions of light years, FAST, it must be operational to 100%. This radio telescope has the ability to perform several types of searches simultaneously. The program is impressive. We find pulsars, neutral hydrogen and dark energy. Everything begins with a mission worthy of the best science fiction novels. FAST elaborates a map that will allow us to locate ourselves with precision in the immensity of our galaxy. From its origin, man is explorer. His next adventure could well pass on the Latin Road. But to be able to guide through the confines of the cosmos, the explorer of tomorrow will need reference points. Without them, it could be lost in the midst of nowhere, to light years, of all help. If one day we leave the solar system and travel through the galaxy, it will be impossible to communicate with the Earth. We will have to find another way to be able to guide us. Therefore, since 2017, FAST scientists have proposed to map the Milky Way. What are their reference points? Pulsar. Star objects from giant stars almost 10 times larger than our Sun. And like our star, they are not eternal. At the end of his life, they collapse on themselves in the form of supernova, of which only one neutron star will remain. A sphere of about 10 kilometers of diameter with physical properties. It's like a lighthouse. And as it turns very quickly, we can observe the radio wave beam every time it passes through the line of view of the Earth. Its extreme rotation drives radio waves through the universe. Hence his name Pulsar. Thanks to these stellar headlights, future travelers of the cosmos can guide and find the way. His analysis will also lead us to a better understanding of the behavior of gravitational waves and the discovery of black holes. So that locating pulsars has become a priority for PASTO personnel. But cartographic our galaxy is not the only challenge proposed by FAST engineers. October 2019. The power of the radio country allows you to perform several searches at the same time. One of the many promises is to help us understand how the universe developed. For that, scientists began to observe the simplest element and the most present in the cosmos, neutral hydrogen. It accumulates in immense clouds of gas that represent more than half of the visible matter that constitutes the universe. What is known as space emptiness is mainly composed of neutral hydrogen. Its total mass far exceeds that of all the stars of our galaxy. In these clouds of neutral hydrogen is where the stars are born. Observing them, fast should help us better understand the phenomena that allowed the development of the universe. A universe that until today has only revealed 20% of its secrets. Secrets that scientists expect to discover with this new tool. After mapping our galaxy, fast astronomers assumed a new challenge, detecting a form of energy capable of expanding the borders of the universe. No scope in the world has ever been able to demonstrate the existence of such energy. An invisible energy, known as black energy, that worries the scientific community. Is it an unknown matter, an anti-gravitational force? There are many hypotheses, a mystery that fast researchers intend to clarify. To achieve this, they will have to analyze the movements of the universe giants, the basic gas clouds such as the clusters of galaxies that extend over millions of light years. We know where it is, we know how to find it, but we can't see it. To observe something that is transparent, such as air, the best tool is needed. What we call a stream of air is black energy. These stars move like a cloud of smoke in the air. We know that they move in a current of air that we cannot see. With its giant reflector, FAST hopes to discover the nature of the force that has the power to expand the limits of the universe. March of 2020. Finally fastest operational. Once refined, it allowed to combine the different lines of research. Astronomers want to understand the universe studying neutral hydrogen and dark energy. These scientific challenges are not the only ones. Researchers want to discover more than the laws of the cosmos. They also want to listen to what is hidden there. As for example, possible extraterrestrial ways of life. Scientists are looking for radio signals from other places. The universe is immense. If there are aliens, the signals that send us will be very weak when they reach the Earth. Then, orienting fast towards the confines of space, the researchers could discover the unthinkable. We have a very sensitive giant machine. We should make new discoveries. The universe consists of approximately 2 billion galaxies. Our galaxy contains about 300 billion stars and 100 billion planets. With similar figures, civilizations should have appeared in other places in addition to Earth. With its hypersensitive sensor, FAST is currently the essential tool that can allow humanity to intercept the messages emitted by an extraterrestrial civilization. FAST researchers want to go further and maximize the capacities of their radio. FAST specialized in observing immense areas, but it also has to be able to detect the details. It can be said that FAST is like a great-angle objective. You can't see the details of what you observe. For this reason, FASCO teams work in union with international partners who have telescopes whose specificity is to aim at details. For example, when FAS detects a possible pulsar, he needs the help of an Australian telescoper to confirm the discovery. With the time, the ambition is the network connection of several telescopes to create a surface. To connect two telescopes, an observation surface as large as the distance between them is created. If we connect all the satellites together, we could create a telescope to the size of the Earth. The development of such a network will allow man to explore the universe even more deeply. And FAST is part of this network. Allah manufacturing FAST, China has achieved a prominent place among the countries that look at the sky. An impressive machine at all levels. Its reflector of 500 meters in diameter is the largest in the world. The mechanics designed to compensate for the rotation of the Earth is unique. They consider millimeter positioning details. The receiver and its antennas allow listening to the confines of the universe. A tool that was born thanks to the work of engineers, builders and scientists. Katador years of research, almost 10 years of works, thousands of tons of rubble, trucks, cranes, explosions that have allowed the creation of the New World Reference for the observation of the universe. A tool that will allow a leap forward in the understanding of our origins. A tool that wants to demonstrate that we are not alone in the universe.